for these steps, ladies and gentlemen, what I have is f of x equals x squared minus x plus 6 divided by x plus 1. I'm going to ask you guys to graph this, all right? Unfortunately, we can't use the transformations like the graph we did before, right? Because the transformations, we had 1 over x, and we just did, oh, shift left, shift right, shift up, shift down, reflect. But this doesn't look like the reciprocal function, right? We don't have a 1 up top. We have some different things. So what we're going to do is we're going to go through a process, all right? I'm going to show you step by step what all the information you guys need to do. The first is to find the vertical asymptote. So remember, ladies and gentlemen, the vertical asymptote was when you took your polynomial as your denominator and set it equal to 0. The reason being is whenever our denominator was equal to 0, we knew we had an asymptote. So we solve for x. X equals -1. Therefore, when x equals -1, we have 0 in our denominator, right? That means our function is going to be undefined. So when looking at what the graph is going to look like, we go over to -1 and we graph an asymptote, which is just going to be our little dotted line. Now remember, by talking about asymptotes, this is where our graph is going to approach, right? Our graph is going to approach this dotted line. So we need to find some more information. Let's go and see now if there's a horizontal asymptote. So remember, by looking at the horizontal asymptotes, we're going to look at the degree of each polynomial. So right now we have a degree here, we have a degree of 2, and we have a degree of, remember, if it's just a variable, we have a degree of 1. So right now we have 2 is greater than 1, which is the same thing as a of x is greater than b of x. So by looking at your notes, whenever you had your numerator, the degree of your numerator was larger than the degree of your denominator, you had a no horizontal. Now, we next look at this one, and we determine, all right, so if there's no horizontal, there's a possibility for a slant, correct? Yes. Now, for the difference of the slant, the difference of our degrees has to equal 1. And when we do this, we do 2 minus 1 equals 1. So therefore, do we have a slant asymptote? Yes. So to be able to figure this out, to find out what the slant asymptote is, now what we need to do is actually divide the two polynomials. So I'm going to do this, let's do it over here.
Wait, so would you do synthetic division?
You could use synthetic division to do this, but remember, you can only use synthetic division. Only use synthetic division when your divisor is a linear binomial.
Okay.
All right? I am going to go over long division because I think you guys can do synthetic division really easily, right? And not every divisor is going to be binomial. So we're going to want to make sure we review the process of long division. So I'll do long division for the problem. So we have x plus 1 divides into x squared minus x plus 6. So in doing long division, remember we just take the first value in descending order and divide it into our first term. So x divides into x squared, x times. Then, remember, you take that first part of your quotient and you multiply it by each term of your divisor. So x times x is x squared. X times 1 is x. Then, remember, ladies and gentlemen, we subtract the whole row. Just turn it into a black box. So x squared minus x squared, we know now, goes to 0. Negative x minus x. So negative x minus x is a negative 2x. Right? So, and then 6 minus 0 is just going to be 6. So then we do x divides into a negative 2x, negative 2 times. Negative 2 times x is a negative 2x, and negative 2 times 1 is negative 2. Divide the whole row. Negative 2x minus a negative 2x, that goes to 0. 6 minus a negative 2, that goes to 10, which is our remainder. But if you guys look at your notes, we're not going to deal with remainders. All we're concerned about is our quotient. We don't care about the remainder. And I'll explain that to you later. Yes? It's not. It's 8. But it doesn't really matter. It's not going to affect our problem. You're right. It's 8. Right? But it's not going to affect the problem. We're not even going to worry about it. So this is going to be our horizontal asymptote. So we can say our slant asymptote, or not horizontal, our slant is y equals x minus 2. So now, ladies and gentlemen, we need to graph this. Now remember, remember, this is a linear line, right? So how do you graph y equals x minus 2? Well, we remember everything can be put in the form of y equals mx plus b. So b in this case is negative 2. So I go down to negative 2. And then I just follow the slope, which is 1 over 1. So I go up 1, over 1, up 1, over 1. Okay? So that's what our graph looks like right there. Make sense so far? Okay, so now we've done all the asymptotes. So you complete all the asymptotes, you're good. But we haven't talked anything about the graph. So now to graph this function, guys, there's 4 things I'm going to ask you guys to do. The first 2 is I need you guys to plot the x and the y intercepts. So, the x-intercept. The x-intercept is where the graph crosses the x-axis. Remember from linear equations, the x-intercept is when y equals 0. So to find the x-intercept, what we need to do is put a 0 in for y. Well, you can say, well, Mr. McLogan, there is no y. But remember, y and f of x are both the output values. They're really kind of interchangeable. So what I'll do is I'll put 0 equals x squared minus x plus 6 divided by x plus 1. Now you might say, all right, that's kind of difficult to solve for x, right? But to solve for x, the first thing we need to do is get x plus 1 off the bottom. So what I'll do is I'll multiply by x plus 1. Well, x plus 1 times 0 is still 0. X plus 1 divided by x plus 1 divides to 1. So I'm just left with x squared minus x plus 6. Now, do we know how to solve a quadratic when it's set equal to 0? Yeah, you can factor, complete the square, or use quadratic formula. Fortunately for us, this is factorable. So we can say 0 equals x minus 3 times x plus 2. No, that doesn't work. Is that not factorable? Let me make sure I had everything correct. Oh, it's minus 6. My bad.
Oh my god.
That's not going to affect anything here. That still remains the same. That doesn't matter. Sorry. This is a minus 6. I wrote the problem wrong. Sorry, guys. So, therefore, yeah, that would work now. So now we have x minus 3, x plus 2. Therefore, my x-intercepts are at x equals 3 and x equals negative 2. So I go over here and I say x equals 3, 1, 2, 3, and x equals negative 2. So I have 2 x-intercepts. All right? Now, let's find the y-intercept. So if the x-intercept is when y equals 0, the y-intercept is when x equals 0. So all you're simply going to do here is just put 0 in for all the x's. So you could say y equals, or f of x equals, 0 squared minus 0 minus 6 divided by 0 plus 1. So you could say y equals a negative 6 over 1, which equals negative 6. Therefore, the y-intercept is at negative 6. 1, 2, 3, 4, 5, 6. Okay? All right. Now, I said I was going to ask you guys 4 things. Fortunately, by finding the x and y intercepts, you found 3 of them. What I'm asking you guys to do is, once you guys have found all of the asymptotes, all right, what you guys need to do is find 2 points to the left and 2 points to the right of your vertical asymptote. I'll say that again. Once you find your asymptotes, find 2 points to the right, Juliana, and 2 points to the left of your vertical asymptote. I'm not really too concerned on what your graph looks like. You guys have graphing technology for this, right? No, you don't have graphing technology. So I'm not too concerned then about what your graph is going to look like, all right? All I want you guys to do is work on graphing this. So then what you'll do for this problem is, I've already found 2 points to the right just by finding the x and y intercept, right? But I need to find 2 points to the left. I've already found one, now I need to find the other one. So how can I pick another point to the left? Well, you we could say, let's find out what f of negative 3 is. So then what you do is plug in the point f of negative 3 into your function. So what we get is negative 3 squared is 9 plus 3 minus 6 divided by negative 2, which this equals what? Negative 3? 6 divided by negative 2 is negative 3. So therefore, at f of negative 3, 1, 2, 3, we have negative 3. 1, 2, 3. Okay? So there's your 2 points. Now you've computed 2 points to the left and 2 points to the right. So on a test, that's something that you're going to have to show me is those 2 points to the left and 2 points to the right. Find the asymptotes, find the x and y-intercepts, then make sure you have 2 points to the left, 2 points to the right. Now remember, ladies and gentlemen, my graph has to go through these 2 points and approach each one of these asymptotes. So just through kind of my experience, I know that the graph is going to look something like this. Notice how the graph, they both approach the vertical asymptote and they both approach the horizontal asymptote. Okay? That's it. Hello. Hello. No, yeah, that's all that. Oh, I forgot to turn this on. That sucks. There you go. Ha ha.